My talk is going to be a little different than the rest of them. I'll give you a little background. I'm a computer scientist. My area of expertise is in compile optimization, so I'm a compiler guy. But today I'm going to talk about sustainable HPC by collaborating with the private sector and show you a little bit about what we've been doing, I think. Do I do it? Okay, great. So as you can see, it's a very serious subject. It's really one of the last collaborators that we have worked with. It's a program that we went after with the Cleveland Clinic. We have a new brain institute in Las Vegas called the Lou Ruvo Brain Institute. And in this case, we're talking about Alzheimer's, but really we're talking about dementia and ALS and others. This is actually an emerging area for us, for the Cleveland Clinic folks too. We found out last week that we won a very sizable NIH grant. So it was an $11 million grant to do the studies on here. I'm really interested in this because it's actually a time when some of the doctors and some of the clinicians and some of our researchers are actually going to use data analytics and data science. I must not have. There we go. So the first, as I said, we've collaborated with the Cleveland Clinic. It's turned out to be great. So in order to have sustainable HPC, obviously you have to have projects, you have to have money and whatnot, and then you can get on with the science. Another partner of ours is Switch, and Switch is basically for those. In fact, how many people have heard of Switch? So about half. Okay, so Switch is a large data center. They've been kind enough to give us additional space because of some of the equipment we've put up from an award from Intel, which is a 26,000 core machine, and we're about ready to upgrade it again, and I'll talk about that in a minute. But the nice thing about being out at Switch is I basically have unlimited space and power and security and all that kind of stuff. It's also very helpful for me in some of the contracts we're locking down with the federal government. So some of the things out there make the people at Sandia real comfortable because they've got armed guards with guns and all that kind of stuff. But Switch has been instrumental in Switch, and their founder, Rob Roy, has actually given us a 60-month no-cost, let's see how this HPC experiment goes. So right now we still have about 4.5 years left on that, and we can expand. The building I'm in right now is about 525,000. Switch itself, I think, has 1.7 million square feet of data center. They're building a new center out close to the Tesla plant in Reno, which is the gigawatt battery plant. So I've been told that there'll be, within a year, 2.4 million square feet. But at Switch right now, there's no problems. And a lot of you from the big corporations, you don't really feel this, I don't think, as much as universities do. We run out of square footage really fast. So I would not even be able, the first award from Intel was a 9,000 core machine we call Cherry Creek. And I could have put that up in my data center at UNLV. But I would not have been able to expand it out to the 18,000, the 26,000, and now we're talking 60 or 70,000 cores. At Switch, I can do that. Let's see. This is actually a presentation I made last week at the IDC conference, so I'm trying to turn it into something else. You can see two pictures here. The top picture is, again, a brand new building, about 4 years old. That's where the National Supercomputing Center lives, already out of space after 4 years. And then down below is the SCIF we have at Switch Communications. And basically, we are a full-service supercomputing facility. We are a soft money shop, which means we're not receiving any money from the governor's office. Our mission is for excellence in education and research in supercomputing and its application. One important point here, I'm going to make a little pitch for the university. In August of 2017, excuse me, in August of 2017, we'll be opening a new medical school. So the unique thing about it, I don't know how much you know about medical schools, but it takes approximately 5 years to get accredited. So what they have decided is that could be a tough 5 years waiting for really good students to apply. So the first 4 or 5 classes will be fully funded. So if you know any really bright young people that are going after a medical degree and they would like to get out of medical school with zero debt or near zero debt, tell them to look up unlv.edu. It'll be there. This is now talking about the Intel collaboration. So this is a project that we have. We call it Project Cherry Creek. The machine's named Cherry Creek. Right now we've got between 26 and 27,000 cores. It can achieve up to around 500 teraflops. Our center total is around 660 teraflops right now. You can see some of the technology going on there. We're in the process right now of yet another collaboration with the private sector with Cherry Creek. Since Switch is about 6 miles away, we thought it would be very frustrating at the beginning because we would have to come up with the money for a network connection out to Switch. And Rob Roy, again from Switch, gave us 6 pairs of dark fiber. And all we really needed to do was put gear on it. We stood up a couple of Cisco 9000s, achieving about 20 gigabits per second. And we actually went back to talk to Cisco about what we would like to do in the near future, because a mile from Switch is our new technology park. And we think the first 2 customers there are going to be pharmaceutical companies that deal in HPC and deal with big data, and they're very, very concerned about bandwidth and that kind of thing. So Cisco jumped back in a couple of weeks ago and gave us another award of around $1 million. So right now we're building out 2 100 gigabit per second links out. So they'll go from the university out to Switch, out to the internet, and then eventually over to the new technology park. So we do have many projects. We're like anyone, most of the HPC centers. I wouldn't call all of our users, which is roughly between 600 and 700 users right now, I wouldn't call them all HPC. Some of them have very modest means, but you always have that 4 or 5 different projects that can consume the machine totally. Again, this is a great plug for another collaboration we have with Altair. We've had great luck with Altair. We were using, on a couple of crays we were using another management system. I'm not going to say who, but we were having really a difficult time. And when we actually put the Altair software on, my staff was really, really happy. And the users stopped looking for me in the hallway, so that was really good. So again, a kudo for Altair. As far as projects go, we were talking about the Alzheimer's and anything in neurology. We have a new center that was funded by the governor. It's called the Nevada Institute for Personalized Medicine. We brought in a new executive director, which is from Johns Hopkins, and we've staffed it up with approximately 14 faculty, and they are not local to UNLV or the area. So we went after the best talent we could afford. And as you all know, when a faculty member comes in, if they're senior, they probably have a couple of postdocs, they probably have a couple of doctoral candidates, they probably have 4 or 5 graduate students. So we actually went to Intel, and Intel really said they really wanted to find some value in this machine, the machine they had awarded us. So we gave them a list of projects, and they picked out 5 projects, which we call the Intel Fellows. And the Nevada Institute for Personalized Medicine is really great because it is all about genomics and proteomics. Again, we see that as becoming a real opportunity for high-performance computing. And we also see that as a link back to the School of Medicine, which is really important. Obviously, you can see all the really nice things here. My research support analyst, Ron Young, wrote some great things. He's actually the person on the ground, so he's the one who pays all the dues. He's the one who doesn't sleep at night, except when he texts me at 2 in the morning. But the bottom line is he's really happy with what Altair has brought us. It's made it really seamless for us. We've moved back and forth. We're using it on all our machines right now. And if my staff is happy, I'm really happy. And generally, if my staff is happy, the users are happy. And again, I can walk down the hallways when I want to. A couple of the other programs we're dealing with, you can see the top one, quantum dynamics of chemical reactions. That's a very big project for us. Second one is a collaboration with Los Alamos, and this has to do with all the issues related to fracking. And even though gas costs are way down, it's been explained to me that until gas is above the $100 a barrel mark, fracking makes no sense. But the lab is still very interested in solving this problem and trying to clean up the environmental issues that are created by this technique. So this is another group. Again, it'll be a CFD kind of thing, and it's led by a gentleman named Daryl Pepper, who has actually spent the last 2 years as Dianne Feinstein's science advisor here in California. Then we have a project that I know very little about, except they're happy on the machine, they're happy with the Altair software, and this is our group of physicists. So again, I'm back to we've advanced a lot in the last couple of years. I think it primarily has to do with these public-private relationships we're building with the private sector, and we're going to continue to do that. I've been an advocate, and I really do believe that vendors, no matter what space you're living in, whether it's the hardware side or the software side, I think you're probably going to have to play a bigger and bigger role on the research side. I think it's a space you can grow in. I was having this conversation last week with Barry Bowling over at Cray, and he agreed. He said, yeah, they're thinking about it. But I really think a university can't do all by itself, and I think the private sector folks that are in the HPC space are actually going to have to take and actually become leaders in basically strengthening that part of their side of the business. Again, a good kudos for the Altair team. These are some of the contacts, and this is all on the web, so if you need to get a hold of anybody, or if you need to know anything that's technical about the project we're doing with the Lou Ruvo, and that's the NIH grant for COBRE. It's a COBRE Center we're standing up, which stands for Centers of Biomedical Research Excellence. So it's a 5-year program. So, and again, I can see HPC being a major player in this. The last one, not my slide, but we just had a celebration last week when we found out that we won the large NIH grant. And so this is from Jeff Cummings, who's chief of staff at the Lou Ruvo Brain Institute. And he has decided that we need to rename Sin City. You all know what Sin City is, Las Vegas, but he would like us all to start referring to it as Success in Neuroscience. And I'll leave you with that. So, questions?
Questions for Joe? I'm going to just start walking to the side because it's always the case that someone over there wants to ask a question.
Thank you.
No? Okay, I'm going to ask my one question for you, which is, can you say something about the computational requirements around neuroscience? Because it's one of the areas that, I'm apt to make a joke about just because of Alzheimer's and everything, but it's also one of the areas that it seems like there's a large computational need, but I actually don't know what your 14 new faculty members plus cadre of graduate students, what kind of computational power can they actually consume if you were to give it to them?
It's not a traditional HPC community, but I believe it's because they really some of these folks have never had access to it. I think it's a tsunami that has hit them, all the data. Everybody that I talk to, whether it's our group or the group at Johns Hopkins or Broad or whatever, I'm asking them so we can scale up on storage, because storage is going to become one of our, I think, a real challenge. And they're all telling me 30 petabytes in 18 months to 24 months. And I thought, I don't know, it's never realistic. But I go to these other big universities and I talk to the leads in those areas, and everybody gives me the same number, 30 petabytes in 24 months. So I assume they're right. So right now, their challenge, my colleagues at TAC, the Texas Advanced Computing Center in Austin, have told, they like to call them the non-programmers, and in a way they are. because they really haven't made that step into a parallel environment dealing with tens of thousands of cores. So that's their challenge right now, but everything I see them do, I think we're about a year from it. Intel's been doing a great job with us coming in training, so we brought in some people from Intel to help them understand what the hardware's about, how to leave some of the programming environments that they're in right now, the languages, and move into C or C++. That's something that fits Cherry Creek really, really well. So right now, I think it's a wait and see, but the way the process itself is really embarrassingly parallel, so I can see where these codes will become, they can actually use thousands of cores at one time. And if you step from the genomic side, which is roughly, I think, 3 billion markers, and you go up to the proteomics, you're in the 3 or 4 trillion markers. So everything on the RNA side is a magnitude greater. So again, lots of storage, a lot of transport to move data around. The group that's leading the Nevada Institute for Personalized Medicine really wants to become an archive for data. So, and I'm sure there's others in the country too, but I think it's going to be unique. Their goal right now, I don't know how successful they'll be, but their goal right now, and they have the funding, is to sequence every person in Nevada. So if you want. Not everybody wants, but if you want, you'll have that opportunity. Did I answer your question?
Well, thank you.
Okay.
Thank you. Before I move on? Okay, thank you very much. Bye.